Imagine traveling through space and suddenly seeing something that looks like absolutely nothing. No planet, no star, no glowing surface. Just darkness. But that darkness could contain one of the most powerful objects in the universe, a black hole. So, what exactly is a black hole? A black hole is a region of space where an enormous amount of matter has been compressed into an incredibly small area. The result is gravity so powerful that once something gets close enough, it can become impossible for it to escape. And yes, even light cannot escape. But black holes are not giant holes floating around in space. They're objects created by extreme gravity. To understand how one forms, imagine a massive star. For millions of years, a star is fighting a constant battle. Gravity is trying to pull the star inward, while the energy produced inside the star pushes outward. As long as those forces are balanced, the star can remain stable. But eventually, a massive star can run out of the fuel needed to keep that balance. And then, gravity wins. The star begins to collapse under its own enormous weight. The outer parts can explode in a spectacular event called a supernova. But the core can continue collapsing. If that remaining core is massive enough, it can become a black hole. Now, here's where things get really strange. A black hole has a boundary called the event horizon. You can think of the event horizon as the ultimate point of no return. If you're outside it, escape may still be possible, but once you cross it, there is no known way to return. Not even light can escape. That's why black holes appear black. They don't shine like stars. Instead, we detect them by observing what happens around them. For example, imagine a black hole passing near a cloud of gas. The gas can be pulled toward the black hole and begin moving incredibly fast. As it spins around the black hole, it can become extremely hot and release enormous amounts of radiation. This glowing material can make the black hole's surroundings visible to telescopes. And sometimes, black holes can be found because they are interacting with nearby stars. Now imagine you are falling toward one. At first, you might not notice anything unusual. But as you get closer, the gravitational effects become stronger. And something fascinating happens to time. According to Einstein's theory of relativity, gravity affects time. From your perspective, your own clock would seem to tick normally, but someone watching you from far away would see your motion appear to slow as you approach the event horizon. From their perspective, it could look as though you are becoming slower and slower, but from your own perspective, you would continue falling. Eventually you would cross the event horizon. There wouldn't necessarily be a giant wall, wouldn't hit a physical surface. You would simply pass a point beyond which every possible path leads deeper into the black hole. And then the situation becomes much more extreme. If you were falling toward a smaller black hole, the gravitational force on your feet could be dramatically stronger than the force on your head. That difference could stretch your body apart. Scientists call this process spaghetti ficato. And yes, that's actually the scientific term. But here's something surprising. If the black hole were supermassive, you might cross the event horizon without immediately being torn apart. Supermassive black holes can have event horizons enormous enough that the gravitational difference across your body near the horizon could be relatively small. But that doesn't mean you'd survive. As you continued falling deeper, the tidal forces would eventually become catastrophic. And this brings us to one of the biggest mysteries. What happens at the center? According to general relativity, a black hole contains a region called singularity. Our equations suggest that matter could become compressed to an extreme state, and that spacetime itself becomes incredibly distorted. But there's a problem. Our current understanding of physics isn't complete under these conditions. General relativity explains gravity extremely well on large scales. Quantum mechanics explains the tiny world of particles. But inside the deepest regions of a black hole, we need a theory that can describe both. Scientists are still searching for that theory. And that's why black holes aren't just mysterious objects. They're clues. They may help us understand some of the deepest questions about reality itself. But there's another misconception about black holes. They aren't cosmic vacuum cleaners. A black hole doesn't automatically suck in everything around it. If the sun were magically replaced by a black hole with exactly the same mass. Earth would continue orbiting it. The huge problem would be that we would no longer receive sunlight and heat, but Earth wouldn't suddenly fall into the black hole. The danger comes from getting extremely close. So how do scientists find something that doesn't emit light? They look for its effects. They watch stars orbit invisible objects. They observe hot gas spinning around them. They measure gravitational waves created when massive black holes collide, and they can even observe the dark silhouette created by a black hole against the glowing material surrounding it. In 2019, scientists released the first image of a black hole's shadow. It wasn't a normal photograph of the black hole itself. Instead, it showed the dark region surrounded by glowing material. And that image changed the way many people imagine these mysterious objects. But black holes can be even bigger than that. At the center of our Milky Way galaxy is a supermassive black hole called Sagittarius A-star. It has a mass millions of times greater than our sun. And yet, our galaxy continues to orbit around its center. There are also supermassive black holes billions of times more massive than the sun. Some existed when the universe was still incredibly young. How they became so massive so quickly is another mystery scientists are trying to solve. And perhaps that's the most fascinating thing about black holes. Every answer seems to create another question. How exactly does matter behave inside them? What really happens beyond the event horizon? What happens to information that falls inside? Could black holes eventually disappear? And could understanding them help us discover a deeper theory of physics? We don't have all the answers yet, but that's what makes them so fascinating. A black hole isn't simply a monster in space. It's a place where gravity becomes extreme, time behaves strangely, and our understanding of the universe reaches its limits. So the next time you look into the night sky, remember that somewhere out there may be objects so powerful that even light cannot escape them. Objects that can bend space. Objects that can affect time. Objects that can swallow stars, and objects that may hold secrets about the very nature of reality. The universe is enormous, and black holes may be some of its darkest and most fascinating mysteries.